All right, I'm going to go ahead and get started. So welcome everyone once again to this week's edition of Boundary Systems, a PDSVISION company, webinar Wednesday. This week we're going to be talking about regeneration, issues with regeneration and best practices. So before we start our agenda today, our objective is to review and demonstrate regeneration issues and best practices. We're going to start with a little introduction to myself and my company. I'm going to talk about the digital thread just briefly. Then I'm going to jump into the topic at hand. I'm going to divide this into two kind of sections, common causes of failures and resolution tools. I'm then going to do a demo and show some of the causes of errors, and then I'll open it to a Q&A at the very end. So a little bit about me. My name is Sevi Beaver. I've been with PDSVISION since 2019. I have about 8 years CAD experience. At PDSVISION, my focus is introduction classes for Creo, Creo Simulate, and that includes Creo Ansys Simulate, Creo Simulate Live, detailing and drawing, and CAD administration. My company, PDSVISION, we are a technology leader in the CAD, the whole CAD world, really. We work with pretty much all of the PTC products. That includes Creo, Windchill, and several others. And our capabilities with those include consulting, implementing services, training, cloud, and our help desk. We did have a recent name change, so I'm just going to walk through kind of a brief history. We were founded in 2006. In 2008, PDSVISION was founded in Sweden. Jumping ahead to 2014, Boundary Systems, headquartered in Cleveland, expands to South Africa. And about 2018, we were acquired by the PDSVISION Group, the company from Sweden. So we've been part of that group for several years. We really like PDSVISION, clearly, and now we're officially the US branch of that, essentially. We still operate completely independently. Nothing has really changed as of the first of the year besides our email addresses. But if you do see something coming from pdsvision.us, this kind of lays out the history of that. I mentioned that we work with every PTC product pretty extensively, from implementation of that to consulting to training. We also work with some other software as well, which are shown here. Those can include eTraj, Keyshot, Moldex 3D as some of the software we've implemented for some companies. These are just things that fulfill some kind of niche that we think PTC's product suite doesn't quite cover. So we work with these as well. Now I'm just going to talk briefly about this digital thread idea. What this is basically conveying is the idea that we can use current technology of connecting our CAD data with the rest of our development process. So on the inside of this, and kind of thread one, we can see the kind of direct modeling type categories like CAD, simulation, technical publications. And as we go out from there, we can see we have things like change management, automation, project management. Going out another step, we have manufacturing processes. Going out from there, we have smart operations, cloud, etc. So we have a webinar series that has already started. I believe the first digital thread presentation has happened, and we're going to have, I want to say, at least 10 of these coming up. And the idea of that is we're going to have a bunch of webinars showing the same the same model kind of from start to finish. So starting with design in CAD all the way through manufacturing. And we're going to show all the different ways that we can do that in a connected way nowadays by using the whole suite of products available to us. So as I said, this has already started. If you see those webinars coming up, I definitely recommend joining them. The first one was really, really great. As far as this webinar, this is not specific to Digital Thread, but just to kind of mention what kind of topics we're covering. I just kind of circled 3 of these bubbles in red. This webinar specifically, we're going to be working in CAD, we're going to be working in Creo. And this has some applications for CAD management. We're going to talk a little bit about accuracy, stuff like that. And requirements management as well kind of plays into this as well. And here we can see just a little bit of a different view of the digital thread, showing it instead of by the technology, by how most companies are set up, from the planning or sales process to design, to production, to delivery, etc. And this is kind of what we're trying to do, is join all these historically different parts of a company together with technology. So yeah, definitely check these out. I'll be doing, I think, the 8th or 9th one, but in a bit. But we have a lot of these coming up, and they're at least the first one's been really, really good, in my opinion. All right, so that is all my intro stuff, and now I'm going to jump into the topic at hand. As I mentioned, I'm going to kind of break this into 2 sections. The first is going to be causes of regeneration failures. Then I'm going to jump into the tools we have in Creo to actually address this. So I'm going to talk about each of these. At the top, we have part regeneration failures. These are really common things that cause a failure in a part. The first is feature creation is of an invalid result. And below that, I have some examples: inverted surfaces, zero length edges or sketch lines, sweep or thicken radius failures. So this category is going to encompass anything that just can't generate the geometry. If you try and input certain things into a sweep, for example, certain radius, and you try and click that green check mark to complete your feature, it is going to give you a failure because that geometry cannot generate. So I'm going to be looking at a couple examples of this, but I mentioned sweeps, particularly overlapping sweeps, overlap on itself. Also the thicken sketch feature. This is really common as well. We have the same kind of radius issue there, as well as the fact that your sketch needs to just be one section. So I'll show what that means a little bit later as well. But essentially this category is anything that Creo cannot generate the geometry for. That's going to give you an error. The next common cause is missing references. This could be anything from selecting a surface as a reference. That surface, then we make a change later on, that surface doesn't exist anymore. Or it could just be accidentally deleting something that was used previously. But oftentimes we're going to have missing references that are the cause. What we're going to have to do is select a new reference to replace the one that's now invalid. And the last point I have here for part regeneration failures is relative accuracy. In previous versions of Creo, I think up to 7, the default accuracy was relative. So if you did a new part in Creo, you use the default template, it's going to give you relative accuracy. This has recently changed. So again, I want to say Creo 7 or 8, but in the newer versions, you'll now be given absolute accuracy by default. But the reason I bring this up is relative accuracy, which again was the default previously, not anymore. This can cause failures, especially if you are working with very small features in a relatively large part. Relative accuracy is going to essentially determine your accuracy based on the size of your model. So if you have a certain size model, but some very, very small features, then you run into some problems sometimes. Just to explain the accuracy thing a little bit more or in more depth, generally absolute accuracy is going to be recommended for a lot of applications. We can see specifically if you have a large part with small features, that's one of the times absolute is definitely recommended. Additionally, anytime you're doing simulation, absolute accuracy is going to be recommended. The disadvantage to absolute accuracy is it can have slightly slower regeneration times. So generally what we want to consider here is what's going to be the best for our specific application. There are a lot of applications where relative accuracy is not going to be any good, but there are some applications where it can speed up your regeneration. So we just have to be mindful. Going on to assembly regeneration failures, some of these are going to be similar to above, but the first one is not. First one, Creo is unable to locate a required assembly component. There are a couple causes of this, but a couple examples. If you maybe change the name of a file in Windows rather than in Creo, Creo is not going to be able to find that file anymore when it tries to use it in an assembly. Additionally, just accidentally moving something, changing a directory name on your Windows. This is more a problem I found for people working outside of Windchill. But anytime Creo is not able to kind of follow the file path it had previously, or if it's not able to find that file in your working directory, it's going to give you an error. Second, we have accuracy conflicts with assembly features. This is a similar issue of a certain part uses relative accuracy, and you bring it into an assembly, do certain assembly features, you can run into problems. Third, assembly component placement references have become invalid due to feature level changes. So as we're creating our assembly, we're placing components based on references. So similar to above, where features are failing due to missing references, we have the same thing here, where certain changes we make to our model, whether we make it bigger or smaller, it's going to make it so that our initial assembly constraints no longer exist or are no longer valid. And lastly, again, feature placement references are missing, same thing as above. So I'm going to talk about best practices a little bit before I jump into the tools in Creo that we have to resolve these issues. So best practices for parts. I've got quite a few up here about rounds. So first of all, round features should be at or near the end of your model tree. An exception to this would be if you're doing a shell. Shells do want to come after rounds, but besides that, you should do your rounds after at least your main solid modeling. Any kind of these cosmetic features should come at the very end. The reason is they're going to be basically generated they're going to be generated once in the model tree, and then they may have to be regenerated again if you do, for example, a child feature from that round. So oftentimes this will cause your regeneration to slow down quite a bit if you put your rounds early in the model tree. Putting them at the end of the model tree kind of solves that and can speed up your regeneration quite a bit. The next tip is avoid using auto round for complex assemblies. Auto round can cause some problems, especially for complex assemblies. What some people do is they'll use auto rounds, and then they will then kind of one by one convert those rounds into separate features. This is completely fine, but just be very careful about using auto rounds for very complex assemblies. Next, avoid edge rounds where possible. Use surface rounds. This is basically putting intent into our rounds by selecting two surfaces rather than just the edge that's being rounded. This is not only going to make our edges more robust or more resilient to model changes in case that edge length goes to 0 in the future, but it's also going to improve our regeneration times. Next, avoid having or allowing rounds to have child features. So you never want to dimension anything off of a round if possible. As I said, you want to do these rounds last, and this kind of plays into that. Avoid allowing mirrors to have child features, specifically mirrored geometry. Mirror is something you want to do near the end as well. You want to do your design changes on whatever you're going to be mirroring and then mirror that. Anytime you make changes to your initial features, that mirror is going to change as well. So as a result, for regeneration and stability issues, you don't want to reference things off of that mirror. Next, avoid meaningless features. So some examples, we have cuts that do not intersect the model. Creo will actually give you a failure for this in newer versions. So a little bit less relevant nowadays. If you do an extrude remove material and it's not hitting any geometry, that will give you an error. But something to keep in mind, extrudes that fill pre-existing holes or cuts, we can think about that kind of as redundant. We can just edit the original cut or hole to kind of control that without adding additional features to our model tree. And third is datum features without children. Any datum feature without a child is not really doing anything. It's not adding anything to your model, no mass, no thickness. And if it doesn't have children, it's not really doing anything at all. It's worth pointing out, this may be obvious, but anything you do have in your model tree, it's going to slow down your regeneration. As your models get bigger, your regen will slow down, which is fine and normal, but just avoiding meaningless features can speed that up a bit. And use appropriate accuracy, lastly, for the design. I cannot really give you specifics on exact numbers of accuracy you use. That is going to depend on your manufacturing capabilities, your design intent. But I can tell you to avoid relative accuracy in certain scenarios. Specifically in relative to this webinar, when you have a very large part with very small features, you're going to want to use absolute accuracy. It'll slow down your regeneration a tiny bit, but it won't cause your model to fail. So best practices in assembly mode. We have use a skeleton or driving model when possible. If you do not have the advanced assembly extension, you sadly don't have access to skeleton models. You can use a driving model. But essentially what both of these do is they remove references between components. So rather than assembling component B onto component A, we're just assembling both of these components onto predefined datums or surfaces from a skeleton model. So using these can just make your references between your components. It can minimize those. And thus minimize your general potential to make errors. It's kind of just a safer option because it lowers the number of references between your components. Not that any of those are going to cause problems necessarily, but we'll see with circular references that it can sometimes. So skeletons or driving models are always going to be they're always going to increase the reliability of your model, and I recommend using them if you can. Next, we have used the default constraints. Certainly for the first assembly component, and you can do it with additional assembly components if you kind of prepared for this beforehand. The default constraint will align the coordinate system of your component with the coordinate system of the assembly you're putting it in. So what this means, basically, it centers your component in your assembly. You can also design your component a bit offset from its coordinate system. That allows you to use the default constraint to actually do assembling work. You use a default constraint for two different components. They both go to right to the right place. This is a great way to do your designs. You do have to kind of bear it in mind from the very start of the part creation process. You have to know how you're going to assemble this. This is kind of a workaround for using skeleton models. Skeleton models, again, kind of lets you assemble things without references. But default constraint is just a little bit of a different way to do it. You have to think about it right from the start of the creation of the part, but works kind of the same way. The next two, resolve accuracy errors right away and resolve CRC errors right away. These are, I think, really, really important. Generally, errors are just going to build on themselves. As some of you may be aware who have models filled with red failing features, it gets to the point where you can't really fix these things without rebuilding the model. It kind of just gets to a point where these build on each other so much that it's a total disaster, and you can't really resolve these without doing it from scratch. The way around this is just to resolve errors right as they come up. This is a definite best practice, because if we don't do it, it'll eventually cause kind of an avalanche effect of errors. Additionally, we have some config pro settings that have to deal with regeneration in general. These involve family table retrieval, just regeneration in general, what actually regenerates, component retrieval when we're generating assemblies, and mass prop calculations. So we're going to take a little bit of a look later at these configs.pro settings and what those can do for us. All right, so the Creo regen interface, we have two main areas that are going to help us resolve these failures. The first is the regeneration manager. If you were used to early versions of Creo, you may remember the resolve mode. This is not going to be enabled by default, but we can still access this through the regeneration manager. Also through the regen manager, we can control options for backup regeneration models and for mass property regeneration. The notification center is the other tool we have available. Anytime we have an error, we are going to get a little flag in the bottom right of our screen. If we click that, it'll open the notification center. In the notification center, it'll tell us exactly which features or models are failing. And if we hover over those, it'll tell us why they're failing. At least in theory, it tells us something. Whether it's useful or not, we'll see is kind of a gamble. But through here, we can also access edit references and edit definition for that feature, so we can go in and fix it. We can locate it in the model tree. And also here, we can just access notification options. So we can control what gives us an error in Creo, what actually flops up a little red flag in the bottom right of your screen versus an orange flag, etc. Okay, so I'm going to jump into Creo. And I'm going to walk through a couple causes of failures. And we're going to take a look at how to resolve them. So the first and most basic cause of a failure is missing references. So I just have an axis right here, and this hole is placed right on that axis. So I'm just going to delete this axis, and we can guess what happens. Oops, actually did that wrong. So I'm going to delete this, but I'm going to choose not to delete the hole. I'm going to leave it suspended. Okay, and we get a failure. So we can see the current Creo interface. Again, I mentioned it's a little different than before. If you've used older versions of Creo, you might remember a stoplight. The stoplight's gone. So what we have now, we have the feature that failed is going to highlight in red in the model tree and in the graphics window here. And we are going to get a notification. If we click this is going to open our notification center. In here, we have isolated the exact feature that is failing. If we hover over it, it'll tell us something. So this is saying reasons for failure, feature references are missing. So in this case, that's pretty useful. It's telling us missing reference exists, and we're able to just jump right in here into edit definition, edit references, and fix it. So I'm going to click edit definition. We can see that one of my placement references is, it's telling me that it is invalid. So that reference from previously, I'm just going to remove that. And I can just go ahead and make a new one if I'd like. Then go ahead and resume this feature, and it is all fixed. So in this notification center, let's see. Here we go. So in this notification center, just a couple other things we can do. This is going to open our options. So this window is going to control what is going to happen in Creo when we do certain things. For example, circular references. This is going to give us a warning with message, but it's not going to give us an error. Regeneration failed. This is always going to give us an error. We can't even change that one. But as we can see, just certain things that are not necessarily the end of the world, but we probably going to want to know, we can have Creo give us notifications. So the regeneration manager, this is able to be accessed in a couple different ways. We can do that right here from this notification center. So this button on the right of the ribbon up top is going to open the regen manager. In here, if I expand this preferences, we can see create backup models, mass property handling. This will affect your regeneration times, which is why we might want to do that. And plus we have Plus we have this resolve mode interface that lets us troubleshoot in that way if we would like. All right. Moving to my second example. I just have a sketch here. If I go into edit dimension, we can see that this is just a rectangle with some filleted corners, and the radius on all of these, the radius of curvature is 40. That's what I wanted to point out here. So I'm going to make this into a sweep. And just going to draw some geometry to the right of this line. And perfect, it's a square. That's what I wanted. So I'm going to make this 39. So we'll notice that's one below the 40 value. That's this radius of curvature. And you may be able to see what's happening here. If I make this too big, this is basically going to overlap on itself at this corner, and it's going to fail. And the value is the same as this value of curvature, so this radius of curvature is 40. The max value here I'm going to have before a failure is 40. So we can see that this works with something like 35. If I bump this up to 41, it's going to let me create the feature, but it's going to give me a failure. This is an example of a geometry failure. This is just something that cannot be generated by Creo. It'll let you do it all the way up until feature creation, but it's not going to generate. So if I go into my notification center here, what's it tell me? It says cannot construct feature geometry. So that makes a lot of sense. This geometry is just impossible, cannot be generated. So another thing that I want to show here, we have this datum plane. This datum plane is not actually used for anything. I just wanted to show a way we can check that. If I go into my reference viewer, so right click information reference viewer, we can see that this datum plane has no children found. So in that case, we can know that this datum plane, any datum that doesn't have children is useless to us. It's going to be slowing down our regen, so I can safely delete this. Okay, last example for model geometry type things. I'm just going to make an extrude here, and I'm going to do it by thickening a sketch. With this thickened sketch, we have similar radius problems that can come up with a sweep. I'm not going to be talking about those right now. I'm just going to be talking about a different problem we run into with thicken. So I'll first show what thicken actually does. No solid geometry, sketch must be closed. Let's see. So I'm sorry, but I'm just trying to get a very basic thicken sketch going. There we go. So what it's going to do is create solid geometry by actually thickening your sketch. And as a result, you don't have to have a closed section. You can just have something like a line like this. Now, the one exception is this line has to be continuous. And what I mean by that is I have to be able to take my finger and put it down on one end of this line and drag my finger across the entire thing without lifting my finger up. So we can see that that's very possible in this case. I can just drag my finger down like that. But if I do something like this, that is no longer possible. I can drag my finger, so starting at the top, I can drag it to here. But when I go over to here, I would have to lift it up, bring it back. Same thing with this. So these kind of sketches are not going to work for thicken. They're going to cause a geometry failure in the same way. Surfaces are another really common cause of geometry failures. So like something like a boundary blend, if this is creating something that's impossible, if we make a small dimension change, that could cause our surface to fail. And this is caused by the same kind of thing, impossible geometry that Creo just can't generate. Okay, so now I'm going to jump over to this next example where I'm going to talk about accuracy a little bit. So what I did here is I made a very small cut in this model, and I showed that in red. A little bit hard to see, but this is a very thin cut. So this is an example of a small feature in a comparatively large model. Now, if I go to File, Model Properties, we can see that my accuracy is set to relative 0.0012. This exact value was the defaults in previous versions of Creo. Again, I want to say prior to Creo 7, but I could be wrong on the exact date. They might have changed the default to absolute around Creo 6, Creo 7. It was definitely around there. But this used to be the default. The default now is absolute. But if we're working with relative accuracy, just going to show what can happen here. If I just change the dimensions of this by some arbitrary amount, I make this 140 up to 1000. We can see that this second extrude is actually failing. We would think that this extrude or this cut would just go right upward, be placed right here. And it should. The issue we have is with the accuracy. So I'm going to open this regeneration, or rather notification center. I'm going to hover over extrude 2 here. And it says feature geometry cannot be restored. This is an example of when this message is just not going to be helpful at all. Unfortunately, with these kind of these accuracy issues, there's not any indication that that's the issue. Creo is not going to tell you. It is what it is. But that is the cause there. So we can see if I bump this right back down. So let's see, I add a dimension of this, bump it back down to, what was it, about 140. And now the cut is regenerating fine. Additionally, if I change the accuracy, so if I go to model properties, I change this relative to absolute. Now I'll be able to do this with no issue. So I can go ahead and change this to whatever, 1400. And we can see no issue there. Okay, for my last example, oops, I got to jump back here and fix that because I'm using it in my last example. But in my last example, I am talking about circular references. Okay. Okay, so I have an assembly here, and I set it up in a way that gives us a very basic example of a circular reference. So what I did, just to explain what I did here, I have this block is assembled first. We can tell that by the fact that it's first in our model tree. This is just assembled with a default constraint. It's just placed right so that the coordinate systems align right in the middle. I am then I'm then placing this right here, this component right here. This component is placed in reference to this initial component. So I place this component by specifying distance, specifying coincident. We can open that up and see actually. But I've got a coincident constraint between a surface here and a surface there. I've got 2 distance constraints, one from a plane and one from this surface in question. Okay. So what I then do is I actually create a hole. This hole is not actually going through anything right now due to the fact that the circular reference kind of broke it. But I created this hole, and this started causing all of my problems. So what I did is I activated this part in question. And if I edit the definition of this hole, we can see that what I did is I placed this hole in reference to this second component. The second component is below the first component, which is where the hole is being created. It's below it in the model tree. Thus, when we're basically building this, Creo builds it from the top of the model tree down. We're pulling in this part and we're trying to generate a hole, but that hole is constrained by something that's not here yet. So that right there has the potential to cause problems. When I create a hole like that, so let me just fix it so it's in a good spot again. There we go. When I create a hole like this, that's referencing things below it in the model tree. Creo is going to let me do it in the assembly mode, but it can cause problems. We want to avoid this whenever we can. Okay. So kind of walking through again from the beginning, I placed this first block. I placed the second block by using placement references on the first. And then I created a hole on my first block, and that hole is constrained by the location of the second block. So again, that should kind of ring your alarm bells right away, even if it doesn't cause an issue right away. That's just a practice that can cause some circular references down the line. So then as a kind of final step, which really caused my problem, what I did is I created a datum plane that goes right through the center of this hole, or at least it did before I broke it all. And then I actually changed the placement reference of this component to that plane. And this in turn caused a circular reference. Essentially, my part A is referencing B to build a feature, the hole, but part B is referencing that hole to build itself. What this means is Creo runs into a loop. It has to run multiple regenerations, and things still are probably not going to work out how you may want them. So the result is a model that is not very sturdy, not very resilient. You're very prone to more errors in the future. And besides all of that, your regeneration is going to take much more time. So immediately when you want to when you see this, you want to resolve it. This is a very basic example. So this may be easier to resolve than a very big assembly. And that's kind of just another reason why you want to do it very early, right? When you see this error, that's going to give you an idea of what caused it. So you're going to want to address it right away. So when this happens, so when we get a circular reference, we get this notification. It's not going to tell us much in Creo itself. It's not really going to tell us anything actually. But we do, in our working directory, have a file that Creo is going to generate. This is a .crc file, and this is what it's going to look like. Essentially, this is telling us all the different features that are contributing to this problem. This is not the easiest thing to read, so I'm just going to point out feature number and feature ID are how these things are labeled. So I know a datum plane's having an issue, but to know which datum plane's having an issue, I need to turn on some model tree columns. So if I just go to tree columns, I'm going to add feature number, feature ID. We can get these added, so now we might have some idea of what datum plane is causing the issue. I think it's this one. So feature number 6, feature ID 50. Let's just confirm. Yeah, that's the one. And additionally, when looking through this, I generally am looking at these things to see what's having the problems. And we generally want to start in the most kind of the lowest on the totem pole of feature component assembly, if that makes sense. So the place to start here is definitely not going to be this component. It's going to be these holes and datum planes. Now, as I said, this could be a little bit tricky to read, kind of what is referencing what, not the most user-friendly, but the place I'm going to start here is this hole. So I see hole, feature number 7, ID 110. All right, so if I redefine this hole, I'm going to want to do this in a way that doesn't reference this component below it in the model tree. That should be easy enough. I can just change these to datum planes. And I want these assembly datum planes. So I'll do one to, let's see. Yep, that's the one I don't want. All right. Let's see, I'll just select right and front. There we go. All right. Okay. So I'm just going to do file save, and we can see that this model is still not being regenerated properly. We still have a circular reference. So we can see that something else is still causing this. Now, if I just open this file again, sorry about that. And we have to open this with Notepad or something similar. So now I'm going to take a look at this datum plane. We can see that this datum plane is actually repeated twice in this list, which kind of completes the circle of circular references. With this hole no longer here, or no longer at least referencing something below it in the model tree, I'm taking a look at this datum plane. So I'm just going to go ahead and edit the definition of this. We can see it's going through this axis of the hole and parallel to this surface. So these are now direct references of this initial component. But if we go into the definition of this feature placement, so let's take a look in here. We can actually see that that plane is being used as a placement reference here. So this datum, ATM1, this plane I created, assembly datum, is used as a placement reference right here for this other component. So we can just as easily switch this to, nope, not that one, remove. There we go. We can just as easily switch that to the assembly datum plane. It's at the top of our model tree. And regenerate. And our circular reference is gone now. So I guess main takeaways of circular references, or at least the takeaways that I am trying to convey. Number one, you always want to be cautious when creating any kind of feature and referencing something below it in the model tree. Creo's always going to let me activate this top part and then do certain modeling while referencing these other components. Doing this is not always going to cause a problem instantly, but in general, it's a practice you want to avoid because it gives you a big potential for causing problems. So again, when I'm defining this hole on my first component, I don't want to select these as references if I can avoid it. Sometimes you can't avoid it, and sometimes that is sometimes it's not going to give you a circular reference, but it's always a bad practice. And the way around this, ideally, is with skeleton models. We're not going to cover that in too much depth. We have other webinars on the topic of skeleton models. I'm going to redirect you all to our YouTube page at the end of this. And if you have access to skeleton models, I definitely recommend using them to avoid these kind of issues. Okay. So that brings me to the end of my demonstration. I'm going to open it up to Q&A in just a second. I would ask you all to enter any questions that you might have in the GoToWebinar interface. There should be a question spot, and I'll take a look at those in just a minute. Before I sign out, I wanted to mention that while COVID is still very much a part of our lives, we have taken many steps in the last 2 years. We are now getting to a point where training is going full swing once again. We have in-person training that is running that can be on site or in our own training centers. We also still have remote classes as well if you do prefer that format. And additionally, hybrid classes that will sometimes have in-person students and remote students all at the same time. As I said, these are going full swing. We're really excited to get classes back up and running. If you do have any need of classes, definitely reach out to us. Okay, and that is all I got. As I said, our email addresses have changed. So I'm going to be sbeaver@pdsvision.us. If you still have our old email addresses, I'm pretty sure those still work. They just get forwarded to these email addresses. But still probably want to get in the habit of using these. I would also really recommend visiting our YouTube page. So this is still under the name Boundary Systems. This one is not. I should have changed that. Our website itself is pdsvision.us, but our YouTube page is still Boundary Systems YouTube. So this webinar right here is going to be on YouTube in a couple days, and we have a huge catalog of webinars from previous on our YouTube page. So you can definitely check that out. If you need, additional deep dives on any kind of topic, it's probably going to be there. Okay, so we have a couple questions. The first one is just mentioning that Creo 7 is where accuracy was changed to absolute. Thanks for letting me know. So it was Creo 7, and the reason for that was multi-body. I mentioned a few applications where you always want to use absolute accuracy. So I mentioned simulation, a couple other things, but multi-body is also a situation that you're always going to be wanting to use absolute accuracy. If you are using multi-body, again, this is kind of just something that you always want to use if you're using multi-body. Okay. So next question, I mentioned sharing config.pro options, and I did indeed forget. So I'm going to jump over and we're going to take a look at some of those. So I'm going to go into options. First thing to point out, we can also access notification center options from here. I mentioned we can get there from the notification center, but also here. All right, so now as far as specific config.pro options, so I'm gonna go to find. I can't really tell you what to use here, but I can just give you kind of a head start in your search. So if I just search generic here, I know. Let's see. We need the stars. Let's see. There we go. Search descriptions was not on. Okay. So if I just do the keyword generic, so this is going to give us several options that kind of control how the how family tables are kind of handled with regeneration. Additionally, so for additional family table stuff, this is kind of Windchill related in general, I guess. But as far as kind of other keywords we can put in here, so if I search star family, we can see that we have a lot of handling of various family table options. Instance as well. So if I do instance, I actually don't think I need the stars. Let's see. Instance. Yeah, so this is going to give us a lot of family table options that are going to control how things regenerate. Similarly, retrieve. So RETR. So this will basically control what's automatically retrieved as well. We have a whole lot of stuff here. This should at least get you started. As far as specific, kind of specific applications, you can feel free to reach out to me and I will look into kind of specifically what we're trying to do. There are kind of a whole lot of options for these specific things, so it's hard to give specifics without, whatever your specific scenario is, especially as I said, relating to family tables, things like that. So yeah, hopefully that gives at least a little start in looking through these. So I had retrieve, instance, family, and I think one more, generic. These will get you quite a few options just to get started on. Okay. In the notification center setting, what is the difference between an error and a warning? So we should be able to show this. Let's see. So what I'm going to do is I'm going to go to those options and I'm going to make a circular reference and error. If you remember before, it just kind of showed the yellow flag telling us something was wrong, but it let my model regenerate. It let me save it. It kind of just told me something was up, but didn't do anything about it. So now if I try and break this again real quick. I'm just going to do the same thing, constrain this to this second component. And along with that datum plane, this should cause a failure, at least hopefully, or at least a circular reference. Yep, there we go. So now it's giving me basically a red flag, telling me this is really bad, I guess, rather than just a little bad. And that's the main thing here. When I regen and save it, it's going to tell me that I have an error. But that is really the only difference. So we can see again that when I try and save this, since I do have this error, it's gonna tell me you have an error. This is bad news, and yeah, that's kind of the main difference there. So last question, at least the last that we have right now. When importing a step file, large part, which accuracy is better to use, relative or absolute? which accuracy will give the best imported data results? So regards to importing data specifically, I can confidently say that I am not sure. That is something that I can definitely check on with one of my colleagues if there is any kind of accuracy implication for importing step files. The answer to that is I'm not sure if there's anything specific for importing step files. But in general, I would say that kind of just to give general guidance on the accuracy issue. In general, I would definitely recommend absolute, unless you are kind of dealing with slow regeneration times, and that's a real bottleneck for you, and you need to look for ways to somehow speed that up. I would definitely default to absolute. It's going to prevent a lot of things from potentially going wrong. But again, as far as importing step files, there could be something I'm not aware of specific to that application. So Alan, I will definitely check on that and reach out to you, let you know. All right. So I think that is all I have. If anyone has anything else that, any other questions they have for me, anything they'd like to discuss about this topic, any issues they're working through, any models that are a bit overwhelming, feel free to reach out. My email is here on the screen. So yeah, feel free to reach out and I will be happy to help. Thank you so much, everybody. And Josh, I saw your message. I'll send that to you as well. Thanks so much, everybody. I hope you have a great rest of the day, rest of the week, good afternoon. Enjoy the weather and have a good one.